Hey guys, today's lesson is on standard components. And so what does that mean? So a standard component is something that you're going to use in your design that you're going to buy. You're not going to design that piece yourself and have it custom made. You're just going to buy something off the shelf. This could be anything from a screw to a nut to a hinge to a computer monitor or a laptop or whatever. Anything that you're gonna use, but you want to have it in your model, but you don't want to have to, but you're not going to be making it yourself. So for these things, they need to be included in your model somehow. Sometimes they could be as easy as, let's see, I go to this workbench, and so they could be just boxes and cylinders the size of the objects. So that way you know how to space out and you know kind of that they're going to fit on what you're doing. So you can see I've got some boxes in here, a box there. They don't really look like the object they're representing, but they're the right size. And they're kind of to the maximum size dimensions of whatever that object is. And so that's one way to represent a standard component, something that you're just going to buy and you're going to use to add into it. So here I have, this is a press. It doesn't look anything like it. This plate is the right size because that's the mounting plate. And this kind of is just there to show me how much space it's going to be taking up on the bench. So once again, it's just kind of, there's a placeholder so I can see what it is. Sometimes you want your components to have more details. So if you're going to be using screws and especially bolts with nuts and washers and things like that, or hinges, you want to have more ability to see what it's actually going to look like. Maybe you're using a pump. What parts of a pump would be needed to be in high detail? How do you think about that? Okay, you got any ideas? So maybe the mounting holes, where it's going to mount. So let's pull up an image of a pump. So let's say we're going to use this pump here in our design. What would we need? Well, these mounting holes down here, we'd have to know where those are pretty precisely. We'd have to know where this mounting thing here is for this connection. Both the size of this hole here and where those two bolts are and their sizes. We need to know those things precise. What about this over here? Do we need to see all the details here with the little divot and the screws and all the details here? No, this can kind of be rough. It could be just a big cylinder, or it could have a little bit of refinement, kind of with this box coming off, so we can see clearances of other objects there. But it doesn't need to be super detailed. Same thing down here. We don't need to see all these little details here. We mainly need to see where those holes go and the size out here and kind of here to make sure that we have, again, clearance issues. We don't need all the little tiny details in the model. If we can get them, great, but we don't really need them. So a lot of times manufacturers will have files for download. So like if I go here, this is a pretty complicated hinge. It's for like a cabinet door where the door is going to kind of open up and then slide back into the cabinet. So maybe if you've been in a hotel or something, and you've seen that around on the TV, the doors are in front of the TV and then they open and slide back. That's what this slide is for. So there's a kind of a lot of stuff going on here. And this is the manufacturer's website. So kind of, they give us information about it. They give us the full drawings of the hinge, but also we can download a 3D model. We do have to register and sign in. I can't remember my sign in right now, but I could pick all of these different file formats and then hit download if I was signed in, and I'd get a copy of this hinge downloaded that I can add that into my model, and so I can see all the mounting holes. You can see mounting holes here and there and there and everything. I'd see all those perfect. That way I know that what I make when I drill the holes, they're going to line up. So there's a lot of different formats here. So let's talk about these formats a little bit. So in the last video, we talked about ACES solids, right? So a basic 3D model, and its extension is SAT. So this is a really good one to use. We also have SAT files. IronCAD was another original CAD program that didn't quite make the list, but that's a good file for, that also uses the SAT format that ACES had. Step files are good. It's calling Geomagic because that's a name of a current program that uses that, but also Space Claim uses it, but also here's just the generic step file. So step files are good. You also see step files as just STP without the E, because a file extension is really 3 letters. They have a native Inventor file. So if you're working in Inventor, might as well download the Inventor file. If you're working in SolidWorks, might as well download the SolidWorks files. If you're in Solid Edge, they have the X_T. But if you're using an AutoCAD 2D or 3D, we can just download either a 2D or a 3D AutoCAD file. A DXF is kind of a generic 2D file format. And the PDFs are just for looking at those. You can't import those into CAD. So those are great to look at if you're going to just send it to someone else so they can see what you're using, but they're not good for trying to import. So usually when you're going to import, I'd say the SAT, the step. IGES is good sometimes, depending on how they made it. Sometimes that can be a big file. Sometimes it could be a surface model. So kind of mileage may vary with that. STL files, don't use. Those are used when we're going to send something to the 3D printer. It's just a surface model. It has doesn't have any solid information on it. Curves are broken up into facets. So it's kind of your last ditch. If that's all you can find for something, then use an STL. But pretty much anything, any of the other CAD formats is superior to that for importing and using in your model. Like a circle, you have a circle. In all these other formats, it's a circle defined as equal distance from the center. In the STL, it's broken up into a bunch of different triangles, faces. So it's really a kind of a polygon of some sort. And you can't find the center of that when you're trying to use it to find the center of where your screw needs to go. So don't use that when you're doing it. If you find something and you just want to download it and 3D print it, that's fine. Use an STL. But anything else, use a different format. All right. So a lot of manufacturers have files for their parts. They like the pumps, they won't have all the internal stuff, but they will have the outside of it. What we call a shrink wrapped model. That's the name of the term in SolidWorks to do that. You can take a complex model and just shrink wrap it so you get just the outside dimensions, so that someone else could just drop it into their assembly. So that's one place to get stuff. So that was from Accuride. But a lot of vendors, all different kinds, have it. Some of the programs like SolidWorks and Inventor have libraries built in that have some of these components. SolidWorks has a lot of libraries that actually pull components from manufacturers' libraries for a lot of different things, stuff like that. So another one that's good is McMaster-Carr. They've got 3D models of most of their products. So if I go into screws and I pick some kind of screw, pick a size, pick a part number. They'll give me an option for a product detail. I can click on this now, and I can scroll down, and oops, and all I was talking about that, you couldn't see anything I was doing. I was talking with my hands and closed the page. So here was those file formats that you can see here. I need to make sure I look over which screen I'm showing you guys. So these are those formats. So the SAT, the drawing, the 2D and 3D, Inventor, the different ones that use step files, the 3D PDFs, and the STL file. But you can see that this one even lets me orbit around and look at the model, see a picture of it, and see the 2D drawings of that with the sizes and everything. So a lot of manufacturers will have something like this. You can see I can even pick the different models, and it'll change the length of this. Because this is based on a parametric model, it just has a dimension for the length, and when I pick a different model, it changes the length of that. Kind of going back to what we talked about in the last lesson. So there's that. So here's McMaster-Carr. I had gone through, I had picked a screw, kind of worked my way down the list, finally get to something to pick a part number. There's that product detail. I can click that and scroll down, and now I can see the different file formats. So for 3D models, I can do e-drawing. So that's a SolidWorks e-drawing. That's just a viewable thing. Can't import that. Don't use that. Don't use the 3D PDF. You can't import that. We have IGES, we have SATs, and we have steps. They also have some 2D drawings. So just a 2D AutoCAD drawing, a 2D DXF, a 2D PDF, which is just this page, and a 2D SolidWorks drawing. So if you're doing stuff in 2D and you need the screw, import the 2D drawing or the 2D DXF. If you're working in 3D, use one of these formats. Great thing about Fusion is that if I'm in here, I'm just going to start a new design, and I go to Insert, McMaster-Carr component, it opens up that web page right here. I can go through and navigate to it. What I usually like to do though is I will open up this, find what I want just on the regular website, and then I can just copy and paste the part number. That way if something messes up, I don't have to go through all the steps of finding it again. So I'm just going to go search, paste the part number, and it's going to go to the exact part. Now I can just go product detail, scroll down. You can see there's a lot of information it gives me about this. The screw. I'm going to scroll down and then kind of go over and somewhere, there it is. So it kind of moved below it. I'm going to pick that SAT file and I'm going to hit save. And voila, I downloaded it, imported it, and I just hit OK. And now that screw is here in my file. So Fusion's having some issues, but there, now this is here. I can use it. I could go back and look at what that is. So what size is that? That was an 832. So maybe I need to find the nut for that now. So now I can go grab the nuts, do a hex nut. That was an 832. I'll just do a low strength. Highlight and copy that part number. Go back over here, insert McMaster-Carr component, paste that in. Product detail. Get the SAT. And there we go. Voila. Just tilt it up, move it over. There we go. So now I have the screw and the nut. It works. You don't need to worry about, we'll talk about lining them up precisely later on, But if I do go in and look at that section analysis, you can see that, oh, hey, I did a good job. I actually made the teeth line up. I was trying to show you what happened, not to worry about if the teeth didn't line up. So if when you insert it, the teeth don't line up like that, not a big deal. Don't worry about things like that. Because we just need to turn this and then they would line up. So don't worry about that if the teeth don't line up just right. We're just wanting to show the overall thing. So a couple other places to get things. For more complex things, GrabCAD is a great place. So if you go to GrabCAD and go to the community, you can go to library, and they've got all kinds of stuff here. So they've got 3D models of 3D printers, of cars, of boats, hinges. For hinges, I'd probably get it from McMaster, but you know, a V8, pallet processing machine, all kinds of stuff. So like if you wanted to put a computer monitor into your model, there we go. I've got a bunch of different files here. I can go down and look and find the one that I want. Oh, look, there's one with an arm. There's just a Visa mount. Here's one that's a monitor with a mount. There's a curved one. Let's say I want this one. So I can click on it and come down here and I can look and see what formats they have it in. So this person drew it in SolidWorks. And they included 2 pictures and a video. So if I wanted to, I could just hit download all files, or I can just click here and download the file. So you do need to sign in to use GrabCAD. It's a thing that I would recommend doing, because I could just download this. Let's say I wanted to use it. I want to download that. So it downloads the file. And now I want to put this into Fusion. So I'm going to put it into the same file here, or into here. So what I'm going to do is just, I'm going to open my project. Oops. I want to minimize that. So I'm going to hit upload, select files, go to my downloads, and there it is. Hit open and hit upload. And it's going to upload that file. And I might need to wait a little while. I could have renamed that file so that way when it imported it would have a different name rather than underscore equals 8 underscore. So let's wait. You can close this while it works. Oh, it just finished. If I double click, it's going to open that file. Ta-da. Oh, just kind of missing a few things. It's a floating monitor. But so that's the file that it imported. If I want to add this file into the current one I'm working on, I can just click it and drag it and drop it. Oop. I have to save this file first. You can't do that into an unknown file. So that goes back to a few days ago. As soon as you create a file, save it. That way you don't run into things like this. So now I can click it and drag it. And now I can just rotate it and move it. And hit OK. And there it is. And you can see it has this little chain icon because it's linked to this file. So if I change this file, it'll update here. On this new versions, I can even edit here somehow. Oh, right there, hit edit in place. Now if I change something, so like decide that I grab that body, I'm gonna move it down so it actually touches. Let's see, I put it there, hit OK. And now I hit OK. And I save. You can see over here it changed also. If I open this file, oh, see, the blue circle means it's saving and it's re-uploading it. So if I double click, Now you can see it's changed it here on this file. And it worked the other way. If I change here, it would have not wanted me to change it here. So if I go back and I say, oh, nope, I don't want that. So I'm going to move that back up. I hit save. Okay. Now I close this. I go here and you can see it's giving me a warning. So I can just click that. And it updates, and now that's moved back. So that's how we import things from other places in here. Another place to go and get things is Thingiverse. There's all kinds of stuff here. This is my thing. This is the little propeller thing that I made today to fix this one for my pool. So I drew it here. I drew it, I tested it, it works. So I uploaded it here with all the information so that people, if they search for impeller, the name of the vacuum and the part number, they're gonna find this page so I can download it to use. I had done some upper shields that went with some of the face shields that the college was making. That someone else had designed the main part of the shield. But the hospital wanted a kind of an upper piece to it. So I designed that and I shared it out to everybody. I shared it here and then I posted this link out to other people so they could get to it. Ooh, people make comments. Let's see what they said. Oh, they wanted the 6-hole. Yeah, I don't want to do that. They can do their own. And then some other things I've made, a tablet holder, a headphone holder, stuff like that. But they've got all kinds of stuff here also. All kinds of things from like statues to, print 3D printer test things. Here's the Cybertruck. All kinds of things. And so you can download these files and bring them in also. So it's kind of the same way. A lot of times these will be just STLs though. Like if I open this mask, let's see. Where are the files? There it is, thing files. So that's a website. Yeah, STLs. So those are just the STL files. And so you just go download and print it. You can't make any real good changes to it. So kind of watch out for that here in Thingiverse. On mine, I usually try and upload at least a SAT file so that they can bring that in and make some changes to it. You can also just search for 3D models and whatever your thing is, and there's lots of places that come up with 3D models, some that are free, some that want to charge you. So things like Turbo Squid, there's a mix. Some things are free, some things you have to pay for. So like if look at this, these are all free. Out there, model of Model S, $100. And it shows which formats. So you can get in a Max format. So that's a 3D Max. We'll do that one next semester. 3ds is another 3D Max, and an OBJ. So probably an FBX would be the best one. That's a kind of a generic 3D interchange file that Autodesk developed, and they use a lot in their programs. So that would probably come in okay into Fusion. But I wouldn't pay for that. But if you're doing a rendering, so when you get next semester to the animation class and you really want Model S, maybe go there, maybe find somewhere else that has it for free or not so much. But you can see they've got characters and all kinds of stuff here also. So kind of anywhere you find things that you want to bring into your model to kind of make it so that way you can see that things fit, or that it makes it look more realistic, That's why we use those standard components. For hardware, we definitely want to use that. Might as well. This is all included. Even going into like hinges. Got all these different hinges. I can click on them, and then there's that product detail also. So I can get this file. And the next lab we'll do on Thursday will be bringing in one of these hinges and then making it move. So, all right. I hope that kind of gives you a little kind of shot in the arm on how to use other components and bring them into Fusion to add into your designs. All right, bye.